When we think about powerful server processor, we usually think that more cores means better performance. But that's not always true. A server might need a small number of extreme powerful cores, while another server might benefit from having a very large number of small, efficient cores. This is exactly why Intel created different Xeon 6 processor families based on two types of CPU cores: performance cores known as P cores and efficient cores known as E cores. So, why did Intel separate them and which type is better for workloads? Let's start with the P cores. P stands for performance. P cores are designed to deliver high performance from each individual CPU core. They are large and more powerful cores designed to handle demanding threads and application where the performance of each individual core matters. For example, imagine a database server processing a complicated query. That task might not benefit as much from simply adding hundreds of small cores. Instead, having a powerful core that can process demanding instructions quickly can make big difference. P-core channels are therefore a strong choice of workloads that depends heavily on per-core performance, such as demanding databases, high-performance computing, and application where latency is important. Now let's look at E-cores. E stands for efficient, but efficient doesn't simply means weak. The idea is to use smaller CPU cores that consumes less power and take up less physical space on the processor. Because each E-core is smaller, Intel can fit many more of them onto a single CPU. This makes E-cores processor particularly interesting for high parallel workloads. Imagine a server handling thousands of web requests. Instead of needing one extreme powerful core for every request, the server can distribute many smaller tasks across a large number of cores. This is where a E-core can provide very high overall through output while maintaining good power efficiency. So why didn't Intel simply create a Xeon processor that combines everything? The answer is that server workloads are extremely different. Data centers don't all need the same type of performance. Some customers care about maximum performance from each individual core. Others care about running as many workloads as possible while keeping power consumption and infrastructure costs under control. If Intel makes every core extremely large and powerful, the processor becomes more complex, consumes more power, and fewer cores can fit into the same physical space. On the other hand, if Intel uses only small efficient cores, the processor can achieve excellent parallel through output, but some applications that depends on very strong individual threads may not perform as well. So Intel's strategy is to differ Xeon 6 designs optimized for different priorities. Let's compare them directly. P processors prioritize performance per core. E processors prioritize high through output and efficiency across many cores. Think about it like a restaurant. A P core system is likely having a smaller team of highly skilled chefs. Each chef can handle complicated orders very quickly. An ecosystem is more likely having much larger team where each worker handles simpler order efficiently. If you have few complicated orders, the highly skilled chefs are useful. But if you suddenly receive thousands of simple orders, having many workers can be much more effective. This is essentially the difference between optimizing for individual performance and optimizing for overall through output. So, which workloads are better suited to each architecture? P-core Xeon processors are particularly useful when application needs strong per-core performance. Example including demanding database workloads, high-performance computing, technical and scientific applications, and other workloads where individual threads can become a performance bottleneck. E-core Xeon processors are well suited to highly parallel scale-out workloads. These can include cloud-native applications, web service, microservices, and workloads where many independent tasks can run at the same time. Another important factor is power efficiency. For large data centers, electricity and cooling can represent a significant part of the operating cost. So being able to achieve a high through output while using less power can be extremely valuable. So are P cores better than E cores? Not really. The better choice depends on the workload. If you prioritize maximum performance from individual cores, P cores are the better fit. If you prioritize is processing a huge number of parallel tasks efficiently, ECOS can make more sense. Intel's decision to create a separate Xeon 6 product line is therefore about giving data centers the right processor for the job, rather than trying to make the CPU design perfect for everything. In simple terms, PCOs are about maximizing performance per core, ECOs are about maximizing throughput and efficiency. And that's the main reason Intel split the Xeon 6 server lineup into the different core strategies. Thank you.